The south face of this roof has been used to capture solar energy. The right side of this roof, as you can see, contains 120 evacuated tubes, which are collecting hot water. And through the use of a large retention tank in the basement and the hydronically heated basement floor slab, are able to produce all the domestic hot water for this home, as well as the shoulder seasons of heating. The left side of this roof has 10 photovoltaic panels on it, which is a 2 kilowatt array. They are backfeeding the electrical grid through a second meter on this home. One meter will measure how much power this home produces, while the other meter will measure how much this home consumes. These panels are capable of producing 1/5 of the home's energy needs, but through the feed-in tariff program, this home will actually be producing a check for the homeowners which is greater than the bill they will be paying for the power they are using in this home. The net result to the homeowner obviously is that they will be up at the end of every year after having heated and used power inside this home. The driveway paving we've used on this house is a permeable high albedo paver. The reason these pavers were used is that they are a reflective surface which reduces heat islands, as well as any rain which falls on this driveway actually soaks through these pavers into the groundwater table underneath this home, instead of running out onto the street, into the storm sewers, and into the rivers and streams untreated. One of the water conserving systems we have used on this house is rainwater catchment. Buried beneath me is a 5,000 litre cistern, which is capturing all the rainwater that falls on this roof, and through a series of drains connects all the rainwater liters to this cistern. This cistern is in turn connected to an irrigation system, which is buried in the lot, and through the use of a weather monitor ensures that the system does not come on unless the lawn actually requires watering. This lot has been landscaped using drought-tolerant sods and drought-tolerant species to ensure that its watering requirements are kept to a minimum. This system obviously is ensuring that we are not using potable water for irrigating the lot. To reduce this home's energy consumption, we have also improved the building's envelope from the basement to the roof. In the basement, the floor slab is sitting on 2 inches of rigid foam insulation, which is providing it an R10 insulation level. The foundation itself was constructed using the MVIC ICF, or insulated concrete form foundation system, where there are 2.5 inches of foam to the outside, 2.5 inches of foam to the inside, with a 6-inch concrete core. This completely isolates the concrete from the moisture in the ground outside of the foundation. The stud wall cavities have been fully insulated with low-density foam sprayed in place, which improves the air barrier within this house. The entire home was wrapped with Tyvek insulation, and all penetrations, mechanical or window penetrations, have been sealed with gaskets, again to improve the air tightness of the home. The attic ceiling has been sprayed with 6 inches of foam insulation, which completely seals it for air infiltration. And then there was cellulose put on top of that, resulting in roughly an R60 insulation in the ceiling. The net result is a building envelope that's extremely airtight. The air barrier system has been greatly improved, while the energy consumption of this house has been greatly reduced.